All right. Welcome on in, everyone. Good to see ya. We had a little challenge yesterday where we ended stream early accidentally, probably with some button click. I might have clicked a button and it stopped. It stopped a little early. Today, though, we're going to start off where we left off exactly, and we need to finish our optimizer. We've got our criterion, which is obviously not fitting in the right spot. We can make it fit. Don't worry, we'll make it fit. Then we need to train the model. And also, while we're doing that, I grabbed some data. I grabbed a little bit of data. By data here. Let's see, where did I put it? All text. Here we go. So this is all of Steven talking. Hey, Quick Fix. Hi, your moderator is here. Quick Fix, thank you for joining. Welcome on in. Happy Thursday already. We're almost to the weekend. That's crazy. All right, I'm actually kind of excited about this. This is great. I see. This is me talking right here. This is me talking. All of this right here. You see all these subtitles? They're all saved right here, and that's me talking. And I think there's like 620,000 words. That's a lot of words. It's all me talking. Do you already have a MC server running? Oh, Quick Fix. I have the server. I didn't start it yet because what I have to do is a couple extra things. Hey, Gabby. Good to see you. Welcome on in. Happy Thursday. Quick Fix. We probably can get something set up. I had a bunch of other things that I wanted to take care of through the day. Hey, Torva. Good to see you. Hello. Welcome on in. Happy Thursday. How was the day? So far, so good. I built something amazing. I did something that all of our team has been asking for years. And I'm like, okay, I'm just going to build it right now. I'm going to build it. How's it going there, Smeet Desia? Good to see ya. Smeet Desai. How do you say your name? 2065. You're in the future. Welcome from the future. What is that? It was, I'll tell you, it's an MCP that gives access to all of our data systems to our employees. Wouldn't that be great if every employee had access to all of the data in the company, and then it gives them the power and control to be able to make decisions and, understand how the systems and data work? They can run their own reports, their own queries, do whatever they need to get the data to make them successful. Every employee. Wouldn't that be great? That's what I built. That leaks the data. Oh, I know. Don't worry. It's still guarded, though. It's still guarded. You have to have very specific credentials, access control, and several other two-factor things that I'm not going to mention for security purposes. So it's, yeah. Hola, how's it going there? Nazki codes. Wait. Zaki codes. Hey, Zaki codes, welcome on in. Good to see ya. Now open up the hackers to like me. Well, maybe. Don't worry. I was very, very curious. I have a lot of focus on security. Like, I'm very cautious. That's the right word. I'm very cautious. So I've locked it down hard. Yeah, it's really locked down. Please keep it in English, no Spanish. Oh, is that what's going on? Okay, sorry. All right, no worries. Okay, so you guys, let's get the next song going here. And let's get on with our criterion, right? Our criterion. We got to get our criterion working. This is the part to do. We got to fix this right here. Hey, Ruchit, good to see ya. Welcome on in. Happy Thursday. We're almost on the weekend. We're almost there. Good to have you here. Do you have a hacker friend? I do. I do have a hacker friend. I do. A lot of people out there. I have someone very specific in mind. Absolutely. Okay, so we have this Bonzupi. Bonzupi wrote this function for us, and I think I want to try to use it. Let's see if we can make it happen. I think it's possible, and it may work, it may not. Who knows? We're gonna try it. So let me bring this back, and we are gonna see if we can fix this. All right. Oh wait, no. Of course. Okay, yeah. I'm like, it works. It's magic. No, it's not done yet. There's gonna be a panic. How did they learn hacking? You use tools, you understand the systems, and you find, exploits and vulnerabilities where people didn't think to patch things, right? Usually, the hacking is social hacking, right? So if you're a hacker, check this out. This is what you're gonna do. You just talk to someone who has access, and you trick them into giving it to you. That's it. That's the way people hack. And not only today and age, because everything's more secure, not really. It was the trick back in the day as well. You just called someone up. Hey, I'm doing maintenance. I need your help. What's the number, IP address, or whatever? You create an auto-healing agent which can heal your HTML, CSS, and JavaScript files. Ooh, very nice. Currently creating a full max-out version with the new features. Hey, Ruchi, you're making the right call. I like it when things work. Don't you? I like it better when things work. I think it's a lot better. Okay, so let's see if we can make this here. Okay, so I need to, this is our Vim. This is Vim. This is our, we're gonna close this. We're gonna say, all right, so we need to deactivate. And then we need to activate our source. Okay, source, virtual environment, bin, activate. All right, now we got access to our torch library. You want to see that? Then I can share it in GitHub repo. Ooh, yeah, that would be great. I'm very curious about it. Absolutely. All right, so what do we want to do now? We want to say run. I want to say cargo run. Cargo run. R-U-N-N. There, perfect. There we go. And the panic. Here goes the panic. Okay. So our problem is right here. It only, because of negative log likelihood loss, it mandates a 1 or 2D matrices, right? 1 or 2D. And in this case, we can only do batch and logits. So if we can do batch and logits, that means our sequence is going to be part that's broken. So how do we make that work, right? How is that even going to work? You need a mentor who can teach you hacking. Ooh, Gabby, I don't know if you want. I don't know about that. I don't know, Gabby. That's not a. I mean, you want. Are you talking about like pen testing and the good side of like checking for vulnerabilities and reporting and being a good citizen, or are you talking about the dark arts? Right? Read my message aloud. All right, quick fix. Hey, Steven, can you give me access to PubNub's backend so I can check it? Yeah, I know, right? I know what you're talking about there. You just want to take a look real quick. Nothing worried there. Voldemort of hacking, exactly. Andrew MC, exactly. Everything, bro, everything. All right. Well, the answer, Gabby. Of course, I know we talked about this yesterday, but check out Kali Linux as a good starting point. Also take a look at Metasploit, S-P-L-O-I-T. Wait, did I spell that right? Metasploit. There we go. Yeah, I spelled it properly again. So that's another option, right? Those are good starting points. I'd call those really good starting points. How's it going there, Big Mac? Hey, Big Mac! Good to see you. Welcome on in. Happy Thursday. I know, quick fix. I know, right? Oh, you shared it? All right, link. All right, let's check it out. In the link hub. Okay. Wait, I shared GitHub link. Is that comment? No, it's not. You have to put it in Discord. At Rootcheat Discord. It's got to go in Discord. Otherwise, it won't show up. All of them installed, but I don't know how to start. Oh, well, you're on the, okay, so you've got the first part done, right? Then start Metasploit, and it's going to give you a bunch of menus, I believe, right? It's been like 5 years since I've done this. I don't know. And then select some of the tools, try them out. You won't be successful, maybe, initially, but just start playing with them. Get familiar. Just start going in. Here's the idea. Don't prepare, just go. Just go. Do you use Git? Absolutely. Epic Blocks Bow. We got it. Oh, wait, are you talking to Root Cheat, maybe? Red Sun, Yellow Key. Wait, what is that? For this project. Yes, I guess, yes. Git status. Right, here we go. Git log. You can see. Here's all of our logs right there. Right there. What is this? Oh, this is multi-headed attention right there. I just forgot the M. Okay, get status, and we are on okay. Looks it. Okay, sir. Good start. Good start. Early day, sir. Hey, good luck, givers, takers. Good to see ya. Welcome on in. Happy Thursday. Hope you're having a good day so far. All right. On what computer do you train it? This very computer here that I'm running OBS on. This very computer. It's the one right here. Hey, Wanian. I'm currently looking for a person who can manage my computer's advertisements come online. You could use AI for that. You can have your AI automatically make the decisions on what to advertise. We're hiring for many people. Are you interested? Well, let me see here. I guess. All right. So I'm definitely professionally busy on my own company right now, PubNub, API company that allows in-app communication. So you build an app and you want to have users chat or play games. You need a communication API. That's what I do. That's my company. Does it need a 5090? Oh, no, it doesn't. I have a pretty good system right here. And it's integrated, right? So we've got Darwin right there. I don't know if you can see that on your screen. It says Darwin and running on Mac. You can see here, we've got plenty of CPUs, lots of things. Look at all the tabs I have open. Look at this right here. Look at all these tabs. Look at them. These are all Chrome tabs, you guys. Do I have a few Chrome tabs open? You think? Brother, I am in depression. Oh no, Sunjam. You can come back. Don't worry, it's a cycle. Sad, happy, sad, happy. It's just happy. That's how humans do. That's how humans do work. Hey, Alex, good to see you. Welcome on in. Good to have you here. I thought AI needed a good PC. Oh, don't worry. AI does for the large language models. If you want to scale it up, you need H100s. You don't need a 5090 though, if you really want to do some basic stuff. So this is what we're doing here. We're going to create a Steven clone. Where is this? Here's my data. So these are all the words that I've said over the past like 4 months. How many words? 600. Oh wait, hold on. 620,000 words. That's a lot of words. So we need to modify that file so it's all in one line. Probably it would be a good idea to put it all in one line. Though I suppose when we read it, we could just parse it and split by new line character. I think that might be it. Because otherwise the tokenizer is going to. We need to convert the new lines into regular lines. Is what we got to do. Okay, so that's something that we have to do. Let me put that as a to-do item here in our main file. All right, when we load the data, let's see. All right, so to do, convert RN into a space. That's what we have to do right there. Otherwise, we got some problems. We certainly do. Okay. So let me go to our, let's see, that was the wrong file. I want to go into a transformer and then I want to cross. This is where we are currently. Okay. So we need to fix this. Do you guys know? Do you know if this is possible? Yes, there we go. I want to change the view of this, and we need to get the shape. I forgot how to do this. Size 2. Do we have a size 2? Do we have a size 3 somewhere? We do. Okay. So I want to grab this. Say this is batch sequence and logits, right? Out. Size 3. Unwrap. Sounds good. Okay. Then we need to change our view, and our view will be done using. How do we do this here? How do you code ChatGPT in Rust? Oh, Epic Bloxpo. You create the algorithm that drives the intelligence is what you do, right? Right here, self-attention. This is what we wrote. So you just have to follow this paper right here. Attention's all you need, and implement this algorithm right here. which is what we did. We implemented it about a month ago in Python, and now we re-implemented it in Rust. And we're gonna see, is Rust worth it? That's the ultimate question. We've been doing this for a few weeks now, and we need to answer the question, is Rust really? I think Rust probably is worth it. I think that's the answer. Please check it out, Ruchi. Okay, did you send it on Discord? We'll have to go check. Let's see. Let me catch up on some of the chats here, you guys, really quick. Thought I need a good PC. Apple because of repairability. Yeah, yeah, you have to take it in. You can't repair it yourself. There's no component replacement easy. It's not. I want to start coding journey. Oh, hey, yeah, do it. Start the coding journey. You should do it. Oh, it's so exciting. It's really great. I recommend starting with Python because it's a really simple language. It's powerful. It's used in the industry. You need to learn it anyway. You got to learn it anyway. And you're also going to get all the common patterns that you would use with software engineering languages anyways. Flow control, loops, variable assignment expressions, classical programming with class structures, object-oriented programming, functional programming, async programming. It's all built into Python. All right, let's check it out. Mine is Python. There you go. What's your favorite programming language? Probably Python. I mean, here I've got two for different reasons. Rust, well, three. Let's say three. Rust because it's very powerful. You can use it for mission critical systems, and it's going to give you the best cost of operations. It's so financially viable, if you think of it like that. From a business perspective, Rust is the answer. Python, from an ease of use, prototyping, quick data processing, right? So data science, machine learning, things like that. And then I really like JavaScript because that was one of the languages that I really got into a lot back in the day. And then of course I can't forget C. I really like C as well because it's what drove my business, is what created my business. JavaScript, oh, lucky, yeah. Lucky, allied, JavaScript, yeah. All right, let's check out Discord, you guys, really quick. All right, you put it in link share, you said? Or general chat, maybe? Torp. Okay. All right, let's see here. Oh, wait, Ruchit, did you say, GitHub ideas, maybe? Oh, here you go. Okay, found it. Oh, I get a 4 or 4. Uh-oh, Ruchit, didn't work, it didn't work. Okay, C++ is the best. That's a good one. All right, let's do a poll. All right, you guys, let's check this. Look at. I want to say plus. Start a poll. All right. Favorite language? I'll say JavaScript. We'll say Python. We'll say maybe Rust, and then we have C, C sharp, I don't know. I'm not going to put Java in there. You don't get that as an option. I will say other though. You can't choose Java. Go. All right. Let's see what you guys come up with there. Golang. Oh yeah, Clinker plays Golang. It's also a good one. I like that. Okay. All right. The C++ experience is having a memory leak and not being able to find it for the next 5 years. Python, there we go. Yep, or Torva, yep, C++. You got to manage the memory. You guys got to manage the memory. All right. What should I code in for Megatron? Well, I don't know. Mr. Banana, please. What is Megatron? What is that? I know, are you, let's see, asked which tool is the best, hammer, wrench, or screwdriver? That's like asking, yeah, okay, yeah, liminal, yes, okay, good point. They're all different tools, right? They're all different tools. So you can still have a favorite one though, right? You can still say, which one do you like the most? Which one makes you the happiest? All right, you could do that. Now working, check again, okay. Nope, not working. Sorry, not working. Okay, we're going back to coding now. Ruchi, didn't work. Auto heal works, verified. Oh, it does? Let's try it again. Oh, there it goes. Okay, it just took a while to propagate on my side. Okay, let's see here. Local persistent CLI agent designed for autonomous front-end refactoring and visual repair. Headless browser. Oh, nice, you got a headless browser going in there. And then Gemini 2.5 multimodal model eliminates human in the loop. All right. So do you have to set a environmental variable? You do right here. Gemini key. Easy. I like the installation. It would be nice if you could throw it into Docker as well. Do you have Docker? No, you don't have Docker. I like Docker because it encapsulates the whole thing. You can create an image and it runs anywhere. Robots. Sorry, I meant robots. Oh wait, Mr. Banana. Oh wait, I love your videos and want to be exactly the same, but in mechatronics. Oh, robots. Oh, robotics. Yes. Okay. That sounds like fun. I want to make dancing robots. Have you seen dancing robots? They're really neat. Like real, those Tesla dancing robots. Those are fun. Noted down your suggestions. Nice. Very nice. All right. So this looks good. Let's take a look here. Oh. Hey, here's the best part. One file. Easy. I like it. Ooh, look at this. You even have a nice little ASCII logo here. Nice. Very nice. I like that. This is clean. Oh, hey, Ruchit. This is very clean. I like it. You did a very good job. There's a lot of nesting ifs here, though. That's a lot of if nesting. This is a lot of if nesting. Most of the time, you don't necessarily see. Look at this. Look at this code. Do you see any if statements in here? Do you see any? Is there even a single if statement? I mean, it's commented out. Let me comment. So yeah, there's no if statements. I don't use that because this is something that you'll commonly see with more, I guess, maybe seasoned or practiced engineering and development. You don't use a lot of if statements. You use sort of flow, a different kind of flow. It's something that you just kind of get out of eventually. You might have an if statement here or there. You might. It's just something to take into consideration. Like reduce indentation. So see how I see quite a bit of indentation here? Like that's a lot of indentation. So part of it does come from nesting your if statements. Let's see here. This part's okay. This part looks good. I like it. Initialization, ready to go. It works. It looks like it works. Okay, so you've got your commands. So see, for these commands, you could do something different, right? You could have a command switcher, right? And then your run loop here, your run loop shouldn't be this big, right? You should be calling out to other functions inside your run loop. So this is your run loop right here, your while true. You want to call out to functions. You don't want to wrap it like this. So that way, if you wanted to do a keyboard exception when you press Control C, right? You've got your Control C keyboard exception here. You could just put all of this into a single function. And so it's a little bit easier to read and maintain. Now, just some tips for you there. Just some tips. Give me all the suggestions you needed. All right, excellent. How do you stop people from stealing your software ideas while building your company? Well, it's less important about that today because everyone's already has your ideas. They already have your ideas, Alex. They do. They've already got them. If you've got something really novel, you should make a patent. You could do a patent, do a method patent, or some sort an invention, right? Invention patent or method patent, usually a business process. Those can help protect your IP, though they are very costly because if you do need to leverage them, you will have to pay lawyers to take care of that for you, and it's gonna be very expensive. So that might not even be worth it. My recommendation is just build it quickly and get your audience quickly. You have 2 weeks. That's my answer. 2 weeks. 2 weeks, you guys. If you take longer than that, you're risking everything. And it's not anything that you can deal with, right? You're risking wasting your time. You're risking building a whole bunch of things that nobody wants. So really why that 2 week limit is in there is for a lot of reasons. You want to get your audience quick. You want to validate that your product is working, right? And that the users want it. Because usually what's going to happen is you're going to need a pivot. You'll need a pivot. So that's the answer. Oh, hey, how's it going there? Foo Dude, good to see it. In Python, I often use dictionaries as a case statement. Ooh, to avoid if-else function. Ooh, that's nice. Ooh, I love it. Storage of functions and variables. I heard Python have known a switch case. Yes, it's a match statement. It's called a match in Python. In Python, It's a match statement, and it's a switch statement, basically. It's called match. It's just called match. Alex, 2 weeks is short. I know. You only have 2 weeks. That's it. That's all you got. Hey, pro folk, I'm here for the daily dose of motivation. All right, let's code together, you guys. Let's code. All right, let's finish our... So I've got about 2 hours to stream. So about an hour and a half left. Mr. Bananas, should I review software using HTML, CSS, and JavaScript and Python for mobile and desktop? Python is more not really for a platform-specific user interface, right? If you're going to be doing Python, you're going to be building data science, web servers, machine learning, scripting, those sorts of things. For user interfaces, you want to use Kotlin or Swift or maybe C# with Unity. It depends. It's up to you from there. Sharing Drive link on Discord. Wait, sharing Drive link on Discord. Wait, what does that mean? Okay, let me know. So let's get back to our code, you guys. That's what I want to do today. I really want to make sure that I make this work. Oh, it's so good to have you guys here. Okay, let's check this out. Let's see here. Let me see really quick. I want to, what do we call this? This is called our cross entropy loss. We need to view this. We need to create a view, and it's going to be our batch sequence and our, what you call it, the logits, right? Is that going to work? Can we do that? Is that going to do the trick? I don't know. I really don't know. Let's see if it's going to cause any errors. It didn't cause any errors. Okay. Let's see here real quick. Wait, maybe do we have, let me think about this really quick. So did I do this correctly? Loss. So we've got our logits, and then we've got our, we also need to change the view here as well, right? And this is tokens. What is this gonna be? Will it be? I don't know. We need to change this as well, though. So let me think about this really quick. What are we doing today? Hey, Drawing Brothers, good to see you. Welcome on in. Happy Thursday. We're going to be creating the optimizer for our, and the criterion. Currently working on the criterion, which is the loss function to train our transformer. We built a ChatGPT. We built it. Nice, never misuse dictionaries anyways. Yeah, you don't misuse the dictionaries anymore? I like those dictionaries. It counts. You can use them. You're using them. Is it misuse? I mean, kind of. I do, because, right, you could do classical structures, right? Object-oriented. Steven, what are your thoughts on the SpaceX IPO? I think it's pretty impressive. It was kind of inspiring, because here's the deal. All right, let me tell you about this, you guys. Very often, humanity today is kind of self-caring. What does that mean? Or self-caring. Is that bad? Not necessarily. Not necessarily bad. Is self-caring bad? No, it's something that we need to focus on. However, if you're thinking of things like making things better, right? Talking about making things better, making humanity better, right? If we're talking about making humanity better, often people think of charity and donations to make existing humans better off. That might not be the only thing that we should be doing. I think instead, what we should be doing is focusing on future humans and making their lives better, right? Because they're going to be humans too. Do we need to focus only on today's people? Or should we be focusing on the future? Because they're people. It doesn't matter what time they live in. I think we can do a way better job for everyone if we focus on making tomorrow better. Does that make sense? Yeah, let's make tomorrow better and net the benefit for the future people and even today's people. I think that's a better thing to focus on. Tomorrow, not today. Not, oh, they're not donating to all the No, don't care about that. Nope, sorry, it doesn't care. Let's focus on making tomorrow better. 1 to 2 minutes, wait, okay. Sounds good. I think it's really crazy how they managed to inflate the value of the company by that much within 2 graphs. I know. Yeah, for sure. If you're focusing on today and the valuation and all that things, that's not important to me. What's important is how can we make humanity and the future way more amazing? Can we make it brighter, right? Let's invest into the future. Done sending you. Okay. Is this going to work? It does, but it doesn't know what the deal is. All right. Can we do this? Does that look correct? Will they be the same? I think so. Maybe. This will be 1, right? This is 2. This is a 2D tensor, and this is a 1D tensor. I don't know. Let's try it out. Run. Error or no error? What? It didn't work? Although that's a very high loss. Hey, seek the vault. You got here at the right moment. Look at this right here. Oh, look at that. That's something that we haven't seen for 3 weeks. Hey, bro, is your GF single? Oh, hey. Well, good news. There isn't one. There is not. Hey, Nelson Mandela. Good to see ya. Hi, Steven. Welcome on in. Good to have you here. All right. So what do we got? Ruchit. I don't know about that. Hold on. What is that? What is this? It's a danger zone. It's a danger zone. Check your DM. Okay, 1 second. How do I... Here, I'm going to open it up in a different browser, hopefully. Okay, good. Okay. What is this? Oh, it's a video. Auto heal. Okay. Are you guys ready? Let's take a look at auto heal. Hey, Quantum Flight Quantum. Good to see ya. Welcome on in. Happy Thursday. Good to have you here. We almost made it to the weekend. Bro, can you give me your ID Insta? Yes. All right, so that is Stephen Blum Code on IG. There you go. Stephen Blum Code on IG. How's it going there? Mouse to cat. Wait, Mouse to cat, right? Mouse to cat. I like your name, Mouse to cat. You guys have great names. Would it be the same selling a vending machine that makes 4K in 10 months, roughly 400 million? I mean, it would be, oh, right. Okay, Tor, yes. Yeah, I get you. I know what you're talking about. It would be, it was a stark change, right? It was a stark change. All right, let's take a look. Hey, how's it going there, Sugar? YouTube removed the counts. Oh, got removed the counts. Good to see you, Sugar. Welcome on back. Good to have you here. I was wondering how did Rust's fearless concurrency help PubNub? Oh, it's helped us a lot. We've migrated all of our tech over to Rust, and it has given us phenomenal latency. We are now below millisecond latency internally, right? We've beat the millisecond. We are now in microseconds. So that's a huge gain right there, right? We were used to be like about 1 millisecond or 2, right? Now we are in like 200 to 100 millisecond or microseconds, right? Huge performance. That's like a 10x gain of performance right there. 10x. The memory is also managed better, right? We got better memory management, and we can more ruthlessly use concurrency. So we've dramatically improved how we're operating. It is stunning, especially at our scale with over 1 billion devices, right? So that gives you, hey, how's it going there? Kamarana, good to have you here. So wait, what? So we're seeing the healing action happening right now. You've got a target UI, HTML file. You said /heal the target. And then healed the UI, safely deployed. Output target healed. Ooh, nice. So it's a nice little, an editor. Well, okay. Yeah, I mean, it's neat. It's neat that you built this. It is. It's very neat. I mean, oh, check that out. It works now. All in one. Beautiful. Looks very good to me. Very nice. Ruchit, this is neat. How did you get the 2 windows? How are you doing the 2 windows side by side? Because it looks like you've got a terminal window on the left and a browser on the right. Is it just you put them next to each other? Is that it? Hey, George! Thank you yesterday for the 10 gifted. I was thinking about you, George. You know what? Our stream ended early because I think I accidentally clicked a button. Don't worry, I fixed that. The button's not there anymore, George. So we're not going anywhere now. You got us for the long run. Bro, your project is completed. It's very close, Maverick. It's very close. Now what we've done is we've created the criterion and the loss. We just need to get our optimizer, run it through a loop, train it on Steven data, right? Steven data right here. This is me talking. This is over 600,000 words of Steven right here. We're going to train it on Steven. Are you guys ready? We're going to see what it looks like. Half of it's because of the Windows screen setup, and because I don't have... Oh, multi-monitor. Got it. What's Steven data? That's me. That's me talking. You see all the words that you see on the screen right here? It's a lot of words on the screen right there. These are all the words we're currently scrolling through right now, and we're nowhere near, right? How far are we? That is 1% of the words, right? 1% right there. That's a lot of words. We're going to make this AI bot, Steven bot is what we're going to. Data of Steven past live streams. That's it. Yep, data of Steven's past live streams. You got it. I bought new lights, you guys, and this light has been with me for 6 years now. And the new lights are coming because this one's flickering. Okay. So like, look at this. This is me talking. All right, let's talk also. It doesn't work, okay. Reshape imaginary doesn't exist. Not a thing. It's not a thing. It doesn't exist. I know. I remember saying that. All right. A vector. Really, it's that it's wanted to reshape. Yep. Okay. I remember this. View. This is me coding right here. That's me coding. Format screen, the format already exists. Yeah, look at that. Okay, so enough looking into the data. We don't need to see that anymore. Now we need to optimize. So did we already have our optimizer? We did our criterion. All right, here we go, you guys. To do. Oh, wait, if we ask it about God. Look right there. Yeah, talk about puppies. Probably. You know what? I don't know. We'll find out. We'll find out, won't we? I'm actually kind of curious. Is there any... Let's see. By data. Let's look at this. Look for the word puppies. There's a few in here. There's a few. Yep, right there. Hey, Torva. You're right. You're right. Look at that right there. You're right. Okay. You might be right. Okay, let's see if we can fix this. All right, so here we go, to do. So now we need to get our optimizer step. That's what we got. We also got to zero the gradients, right? Let's see if we got to zero the gradients. Zero grads. Okay. And then we need to optimize and backstep. Do you guys know how to do these two things? I know we've got our optimizer around here somewhere. Okay. So we saved our optimizer. So it should be self.optimizer.step, right? So let's see it here. Self.optimizer. Hold on. Self.optimizer.step. This is how you do it in Python. Is this how you do it in Rust? So, reference cannot be borrowed as mutable. Cannot borrow self-optimizer? Why not? Why not? That seems like something that is easily borrowable because this is the only place that we're using it. Bro, it looks 13 and 40 at the same time. Oh yeah, Starve. Hey, how's it? Staphos, good to see you. Welcome on in. Good to have you here. Yeah, I'm in my 40s. Yeah. Just round up. Just all you got to do is round up and you'll get the right answer. Round up, you guys. You'll get the right answer. All right. So something like saving all the dictionaries to say AI, sorry, I don't know the technical term. Something like, yeah, basically, right, exactly. I mean, for the most part, you're right. I want to send a backing of why the SpaceX IPO is just a plain stupid into the Discord. Is a plain stupid into the Discord. Link share. I meant SpaceX currently has a loss of 4 billion. Oh, yeah, well, they're in such giant numbers. The numbers are so high. It doesn't really matter. It's this grow and shrink thing. It's called equity, and it is amazing technology. It's so good. It's so good. Yep, that's how it works. And it's fine. It's actually okay. It seems like, oh no, they lost 4 billion. Doesn't really matter. It doesn't. It's not real. It's pretendo. It's pretendo. It's not. I know everyone looks at the absolute numbers. It really doesn't matter. Let's see. You like my agent? I do. I think it's pretty neat. I mean, here, Ruchi, to be fair, I mean, that is kind of what, anti-gravity and Gemini and, already does, right? The Codex, the Claude, and what you've done, though, is you operationalized it in a way that's pretty neat. I kind of think that's pretty special. So you've got a very purpose-built agent. And here's the great part. You actually built one. You actually built it. You know how few people on the planet build those? Very few. You are very, very in the right spot right now. So I commend you. You did great. You did good. Good job. Good job. Okay. So let me see here. Where do we go next? We need our optimizer working. And right now, we need the and mute on the self train. Why does it want that? All right. So pub function train. It says we need to and mute ourselves because the optimizer is going to change. I didn't know about that. Let me see here. Let me see. Okay. So our optimizer needs to be mutable. Let me see here. How do we do that? Mute optimizer. Optimizer. Here we go. It needs to be mutable? Does it have to be and mutable? That's what I'm worried. That's what I'm wondering about. It just needs to be regular mutable, like this. So I think that might work. Do you guys know? Oh, it's having issues. Expected type. Well, okay. Let's go to line 9. Is it on 9? Okay. How about this? Better? Transformer cannot borrow as mutable. Okay. Oh. Is it because optimizer is going to be mutable? Okay. So then line 40. Oh, wait. This is in main. Let's see here. Let's open up main really quick, you guys. Stephen for President Nelson Mandela. What? We think so? I don't know about that. I don't know about Stephen for President. I don't know about that. Special, and that's what I have to say in my vision, to also see UI. So not like normal, that only read the code, it reads the visual part of it. Oh, hey, that's even more interesting. So you've got a really powerful agent there. Ruchi, you did it. You did it. Let's see, transformer. This will be mute. It built. It built. Okay. Can we step on our optimizer? Step. Is this going to work? Also, we need to zero gradients, right? You can't forget that. I've made that mistake before. All right. Run. Here we go. No errors. No errors. It worked. Okay. So, can we get it back down to 8? Or is it going to... Yeah, okay, good. Okay. Now we need to zero gradients. How do you do that? Do you guys know? We need to figure that out. All right. Google TCH Rust zero gradients. Do you guys know how to do this? Optimizer.zeroGrad. Right there. Easy. Okay. Keep it simple. Oh, wait. Loss.backward. Okay. So we need to do our backward gradient 0, calculate the loss, backward, and then step. Okay. All right. Let's try this. Let's try this. Thank you, man. And now, working on a full max version. Hey, very nice. Very nice. I like it. Looking forward to it. Looking forward to it. Okay. So, let's see here. We need to zero grad. Let me type that so I remember it. I'm going to type it by hand. Self.optimizer.zeroGrad. By typing it, it implants it into my brain a little bit better. This needs to happen typically before loss.backward. All right. Okay. This part, I don't know if that'll work. Let's find out. C, unknown field because I typed it wrong. Okay. Optimizer. There we go. Okay, here we go. Looking good. Now, my epochs and batches. We need to figure out where those are coming from. Are they 1 and 1? Do you guys remember? Let's find out here. Main, train. Right here, it is 1 and 1. Okay. All right. So it's just the number of batches. And in order to calculate the number of batches, I would recommend we remove that because we want to do a full epoch, right? Happy birthday. Whoa, hey, Quantum. 36. Good to see you, Quantum. Welcome on. And Potato Gunner. Hello, can you help me? Hey, Potato Gunner, absolutely. What's your questions? Let us know. Can you give internship in your company? I can. I tried. Nobody wants it. The teams, they're like, we don't have time. We're very busy. We don't have time to, and it would be unfair to have an intern on our team. And some people said we don't need the extra help, which is, definitely just means that, you know what they mean. They're just trying to be nice. And the other people's like, it's unfair if we try because we won't have time to work with them as much to give them the education that they're looking for, right? That's what I got. Those are the feedbacks I got. Stephen for president. Nelson Mandela, thank you. All right, I want to learn coding. Nice. Learn Python. Hey, all right. Print hello world. Yeah, you got it. All right. Is that a good investment? Absolutely. I think so. I mean, you are talking to someone who invested in it, and I might have a bias. I might be biased about it. All right, just a smidge biased. 1 second. My light is flickering. I got new lights. They're on the way. They should be here tomorrow, but I won't install them until like maybe Saturday. If you program the vibration setting, I actually have a part in that. Joe, I have. I could tell you about it later. But it's real. Mr. Blum, Erdem, good to see you. Welcome on in. Happy Thursday. Copilot versus Claude Code. Well, I mean, obviously Claude Code, right? Claude Code is the answer. You got to get your Claude Code going in there. All right, give me the push, man. Make it happen. I think it's really valuable because you need to be able to make decisions, and you can make better decisions if you know and understand the code. It turns out now, as humans, what we're doing is we're just making decisions. And that's what you do as an engineer anyway, right? As an engineer, you just choose what to make the next move to be. Does it need to be a multi-architecture system? Or can you simplify it and have it run in a series of horizontally scalable Docker containers, right? What kind of data shape is it? Like there's so many things that we need, and you need to be able to understand those. And if you learn how to code, I think that's going to take it a long way. A real long way, you guys. Let's wake up some subscribers. Hey, George. Hey, yeah. George, thank you again. Oh, George, yesterday I was so sad that stream ended early. I just wanted to say, because I was really motivated. You motivated me so much. That was really cool. What are the chances that AI takes codes and takes our jobs? Not right now. None right now. Right now, the problem is that everyone thinks that these machines are going to be the next amazing thing, and they are very good. They're really good tools. Think of them as tools. Currently, we don't have anything that is even intelligent. It's just generative. What, George? Hey, what are you doing over there? What are you doing? What? George, my gratitudes to you. Oh, yeah. Hey, look at that. You got one, Erdem. Hey, look at there. Erdem, Cardinal. You got it. Oh, yeah. Hey, look at that right there. Hey, George. That is amazing. Check this out, you guys. A whole bunch of people just got some memberships. Look at that. Some donated memberships right there. Blue Dot, Baltazar. Hey, Baltazar. Cyber something. Yes, wait. Cybernet? Oh, wait. Probably Cybernet, yeah. Kunal. Hey, Kunal. IW Neuron. We've got Colby. NC5. Grateful. Check it out, you guys. Thank you. Say thank you to George. Say thank you, George. Yeah. Say thank you to George. Thank you at George. Okay, I'm gonna type. We're typing this in right now. George Party Poppers. Copy paste. Hey, look at that, George. That's so nice for you to do. You're making me feel like a real streamer. You do. It's like real now. It's not pretend anymore. It's real. You did it. You solidified it. That's what I meant. They'll receive a notification and maybe show up in the chat. That's what you meant about waking the subscribers up. Whoa. Thank you, George. That was so nice. Oh, I appreciate it so much, George. I'm a real streamer now. Check this out. Check it out, you guys. We're a real streamer now. Thank you, George. I appreciate it. That's all I can do. Is all I can say is thank you. I can't say. Here, let's delete the code that we're not using anymore because we don't need it. It's gone. We changed it. We've improved it. Look at all the code that we've made better. All right. So now that we've got our optimizer and it runs, right, successfully. Wait. Actually, I don't even know if it runs now. I don't even know if it runs. So let's try running it here. Oh, George. Vector database. Okay, so we're going to be doing that. So this is something that we're going to do coming up here. Okay. Did you code the cool captions too? Yes, I did. I did. You're right. I've even got it up here, right here. So these are called subtitles, open captions. These are called open captions because you can't turn them off. Only I can. I can turn them on and off, right? That's why they're called open captions because they're on my screen at all time and they're burned into the video. I built this 8 years ago, almost 9 now, right? 8 years ago, right? So many years ago now. And it's open source and it's free forever. You just follow the instructions, really simple, and then you add it into your browser with your OBS. Stephen, my lord, Vizzy. Let's see, good to have you guys here. Okay. Oh, these are so cool, like voice detection. It is, yes, voice detection, exactly. All right, so Erdem, you're talking about our vector database system and RAG vector embeddings. Yes, we will be starting that. We will. So after we finish our transformer, which should either be today or tomorrow, after we finish it, basically the goal is write a transformer in Rust, which is ChatGPT. We're going to write ChatGPT in Rust. Then we are going to train it on Steven's text, which is this right here. You can see that right here. We're going to train it on my speech. And we're going to see if it can talk to myself, basically. Then, once we achieve that, we did it. We did it once we're ready to go. Good to have you guys here. Vizzy here. Good to see you, Vizzy. Billion years? Hey, yeah, busy. It's been a little while. Okay, so optimizer. All right, so we got our optimizer here. We pass that in as a mutable optimizer. It's now owned by the transformer. And we are doing zero gradient, backward calculate the gradients, right? This will calculate gradients. Calculate gradients. And then we optimize, which is the learn, right? This is learning. This is where the AI learns. It's actually learning here. And here's the deal. During training, the AI learns. During inference, the AI is frozen. So it's not really no longer intelligent because it can't change. It's stuck, permanently stuck. Okay. So let me see here real quick. What I want to do is I'm very interested in putting this in a loop now. So let's see if we can make this work. Let's see if this will work now. Main train. Here we go. Let's do 10. We'll do 100 and 100. So this isn't correct. It's not accurate, but I think it's fine for now. Oh, look at that. Oh, yeah. Although it's very slow. It's very slow. Probably because we need to do batches. Or do we have batch sites? We need to throw this on our MPS. The good news is you can see it's learning. It's learning, you guys. Look at that. It's so good. Okay, let's close that out. Hold on. Watch this. Watch this. H-top. All right. Let's see if we can saturate a CPU. Something should go to 100, right? It's not saturated. That's amazing. That's amazing. Wow. Okay. All right. So let me get back to our code here really quick. All right. What I need to do is calculate the number of batches that we need. How many batches do we need? Let's see. Let's figure this out here real quick. How did you teach yourself to code a transformer? I followed the instructions. There's a, it's on the archive papers. It gives you a guide. It's not initially straightforward, but it gives you a guide. And so here's the diagram that really describes it. And then you have the actual algorithm diagrammed out, which is really nice and easy for you. The thing that I didn't know up front was what Q, K, and V were. This is really important. Q, K, and V are projections. There are projection layers. They are also the input. So these are your tokens. Q, K, and V are identical. They are the same thing copied 3 times. V value is all of your, basically your words. K, all your words again. Q, all your words again a 3rd time. All the same. You throw them through the linear layer and you project them. And then it gives you different outputs. So yeah, you just go through it. That's what I did. And you saw it live. We did it on stream, you guys. So it's recorded. You can see it for sure. Okay, so now that we've got this, where is our batch sizes now? So we are getting our batches here, and our batch size is going to be based on the number of batches. Is it though? No, it's batch size. Here we go. And what is our batch size set to? It's set to 128, right? So we set it over here. Let's grab into our main file. So that is called train, I believe here. And yeah, 128. Okay. We should probably set this to 256. And then save that. Now what we need to do is, where are we at now? Let me think about this. Where should we go next? What should we do next? We need to do a couple things. So we have to, wait. Train on data. Yes, okay. So change data to Steven. And then we need to, when we load the data, we need to convert new line characters into spaces, or we can pre-process it, right? We can pre-process. Let's see if we can do that really quick. All right, let's jump into it. CD data, head, data, well, no, what is this called? Head all. Here, let's rename this. MV all.text to Steven. Steven.text. So we know so we get a better idea what this is. All right. Okay. And then we're going to do head Steven. So we see like a few of the lines. TR. Can we do a TR? We say like a new line character with a space. Will that work? That right there. That did it right there. Oh my goodness. That took 2 seconds. Okay. So let's see this. Well, here, let me do this. MV Steven back to all.text. And then we're going to do all.text. And then we're going to pass this to Steven.txt, like that. Nice, it's all in one line now. So we will pre-process it. We'll pre-process it. Now let's do 100% of the data. Cat all, boom. Instant right there. 3 megabytes all on one line. Look at that right there. Easy. Okay. Done. All right. So it's called Steven.data. All right, Mr. Steven, my lord. What? Well, you didn't say my lord. Do you have an email or something? Yeah. I do. You can find it on my LinkedIn, my GitHub profile here. So you just find it here in my profile. Right there. There you go. Right there on my profile. All right. Let's continue onward with our adventure. Change to Steven. You know what? Let's just do that right now. Steven.text. Done. Actual data. Done. Complete. Save. Okay. Now, let's try running it. And then we need to migrate to MPS. Is what we have to do. We have to migrate to MPS. 10. Is it going to reduce? Is it going to reduce? 8. All right. There we go. That's what I like to see. One more step. I want one more step before we go to MPS. All right, perfect. 6. I like it. Okay. So now we need to do a device. So we've got our device here. Let's do MPS. Now, this is going to fully work immediately. We're going to see some problems, I believe. Maybe. Let's find out. It might just magically work. I don't know. I don't think so. I feel like it's going to miss some points. Yeah, I figured. All right, so this is because our devices don't match. Placeholder storage has not been allocated on MPS. Where is this placeholder storage? Anywhere a device is used. Device. So here, looks good. Okay, right there, looks good. Okay, device, positional encodings. All right, that grabs the device there. Because it's just an enum, So where we got here, we need to figure out where specifically. Did it say? It would be nice if it gave me the line number. That would be really nice, wouldn't it? Wouldn't that be nice? Yeah, it would. Yeah, Worcester, Stephen, absolutely it would be nice. We wouldn't get the line number for this whenever we get these stack exceptions from C. Yeah, Potato Gunner, all right. Hello, Stephen. I want to contribute in your company any way possible I can. That would be great. That would be. I'll let you know. So we do have some roles open. I believe we have currently one. Let's double check. Let's take a look here. Let's go to PubNub careers. There we go. All right. We have a Rust engineer, core systems Rust engineer. That's the current open role that we have. We had an AI engineer role open as well, and a couple others. They got filled in. Hey, Kyle, good to see you. Welcome on in. Happy Thursday. Good to have you here. All right, so we're going to finish our Stephen GPT now. I just need to get the MPS working. So where's our device at? Device. CPU. Do we have any CPUs in here? No? Okay. So we need to match all the devices before this will work. Otherwise, if we can't get it to run on our GPU, it's going to fail. It's going to absolutely fail. Let's see. Rust transformer frame. Yep. Okay. Frame 26. It would be nice if it told us where this is at. Specifically, which tensor. Because I've got more than a few. Right? I've got more than a few. Do they all default to CPU? Is that what's going on? Okay. Let's close this out here. All right. Tensor. Oh, our input data. Right. Okay. Our input data is on. So, let me see here. Can we say device? When we create a tensor, can we say device? All right. Google TCH tensor set device. See how we can do this real quick. You don't need a job, just gain experience and truly learn. Learning is your goal. That's a great goal. That is a good goal. To device. Okay. So we need to set the to device on this. All right. Perfect. Okay. Wherever we create a tensor, we need a to device. We need to set it on the device. Okay. So that's a lot. That's a lot of work, you guys. That's a lot of work. Dot to device. Say device. Device. There we go. Right there. Okay. Yeah. All right. So we need to copy and paste this everywhere where we've got tensors. Wherever our tensors live. Tensor tokens. We say to device there. All right. Embedding. Or is the embedding already set to the device? I don't know. I don't think so. Because it's learned parameters, right? It's learned parameters. Just implemented dynamic categorization. Oh, Kyle, nice! LiveKit and PubNubs, LLMs, SDKs, and APIs. Also, lives are enabled with guests. Wait, what does that mean? Meaning you can invite people to the live and share content in the items? What? You're making a full-on platform there, Kyle. That's amazing. You're building something pretty. All right, now you've got. Yeah, I see what you're doing now. Split screen? No way. That's so cool. That's amazing. All right, we need to do our devices here, you guys. We got a lot of devices around here. For embeddings, what about when we create an embedding here. All right, so do we need to set the device on this, for example? All right, set device for embedding. All right, let's see if we can do this. Do we need to? La la la. Default. Okay. Var store device. Oh, we already set it the var store. So if it already has the var store, we do not need to bother with it. All right, so we've got VS. Perfect. Okay. So the only thing we need to deal with are tensors now. Just the tensors. So wherever tensors live. So we just need this here. Okay, so this is a lot of work. We're going to take care of it real quick. The agents are giving less errors and seems to be well aligned with your vision. Finally, that's improving production. Hey, that's great. You've hit a stride. That's very good. That's very nice. 2 devices and exist. All right, so I have self device though. I do self.device. About that? Yeah, there we go. Okay. Don't need to worry about these guys. Don't need to worry about these. We might need... No, it's a var store, so we don't need to worry about that right now. Okay. Wherever we create a tensor. Yep. Features. And so these... Yes. So this should be to.toDevice. Self.device. We redo that here. Yes. Okay. All right. And now we probably... Do we want, for this final output here, before we do this, I'm going to comment this out to make sure that we are seeing success. All right, 1 second. Okay. All right, let's see if it works now. Success or no? Are you using Vim? Dadam Ana. Yes, we are using... Did it crash? It didn't crash this time, but it's very slow. Or isn't it? Oh no, it's actually doing what it's supposed to. Hold on. Wait. 1 second. I think we fixed it. Out.print. Let's try it. Please. Yeah, okay. Good. Excellent. Yeah, exactly. Yes, we are using Vim. This is our Vim text editor right here. You got it right there. We got our Vim going. All right. We are currently building ChatGPT in Rust. We've got our data. We've got our criterion. We've got our optimizer. We are now setting the compute to run on our GPU. So that way we can actually train it. So that's what we're doing next. He's using Vim. Yeah, certainly deal. You got it. So now what I need to do is figure out... So this is fine. Don't need to worry about that. This part I am not sure about. I think this is fine here because we're not doing anything special. 0 back step. Is that it? Did we do it? Is there anything else that we need to do? Please work. Well, if it doesn't, we can. There it goes. MPS float. Look how much faster it's going. There it goes. All right, it's training. Hey, look at that. Oh, it's learning how to talk like Steven. Okay. Oh, it's definitely causing some slowdown though. All right. Wait. That caused stream to freeze a smidge. Wait, just a smidgen. Let's see. Maybe we can reduce the batches. I could see that. That was like really crazy. Please re-welcome. All right, Quick Fix, you're back. Good to see ya. Quick Fix, welcome on in. Stephen, my lord, I just call my American friends my lord. Oh, got it. Okay, understood. So since this is, let me see, batch size. Let me see, 1 second. Source, main. We did it, you guys. This is so good. Train. And we are going to set the batch size. Let's set the batch size down to something a little bit more manageable, like 64. All right. Now, let's see if it doesn't cause stream to freeze so much. All right, let's try it. Are we freezing? Is things happening? Oh, there it goes. All right. Are we? It's a little bit, but it's not as bad. Okay. Don't care, let it train. All right, we'll let it train. There it goes. It's learning. It's certainly learning. Oh, look at that. Oh, that's so cool. Oh, nope. No. Oh, okay. So what we're going to have to do is we'll have to probably train this off stream because it's definitely not doing exactly what I want. Because in order to really get it to go as fast as we need to, we really have to do like a 256. We really have to do 256. That's the only option. It's really the only option available. Let's see. Can I... It's going so fast. It was going pretty fast, right? Here, let's try it again. So it needs to learn a lot of text. Like a lot. Yeah, there it goes. Below 4. All right. Looking good. Below 3. Can we get below 3? Yeah, all right, there it goes. Below 3. Almost there. It does. Oh, it's learning so much, you guys. It's learning so much. It has a ton. Wait. Hey, Michael. Thank you for subscribing and joining the right channel for software engineering. As you can see, what we're doing right now is we're building a ChatGPT, and we're building it on my speech. All these subtitles here, right? All these open captions. It's almost below 3. Check that out. Michael Garanald, thank you again. Appreciate it. Thank you for subscribing. Can we name it? Yeah. What should we name it, you guys? What should we call it? And it's definitely getting some a little bit of running into issues there. Is it? Can we tell? Hold on 1 second. Let's see. Split. H top. All right. Let's make sure that. Oh. Ooh. Ah, right there. Okay. This is why. Right here. We ran out of memory. This is what's going on. Okay. Let's close that. Yep, we ran out of memory. That's what happened. See this right here? That's not good. That is not good. All right. Crab GPT. Hey, yeah, exactly. There you go. I like it. Round-head human. Say hi to round-headed folks here. All right, got the round-headed folks. Good to see you, round-headed. Welcome on in. Humanity, you guys. Jarvis. Ooh. All right, here, let's do it. All right, let's give us a few names, you guys. So we've got Crab GPT. We've got Jarvis. I like that one. Jarvis, right? Jarvis, right? And then what are some other ideas? Even if it's not impressive. What is the differentiator? Oh, for this, the differentiator here. Let me try running this again. Oh, look at that. Ooh, look at that memory. Oh, that's a problem. See, this is why I busted it. This is why it's busted right here. See, yep, gotta close it. Okay. So we've got a leak. We've got a leak somewhere. Somewhere we got a leak, you guys. Steven GPT, Rust GPT. Hey, there we go. All right, so we got a lot of options. All right. Bbot. Ooh, Bbot. I like that. Okay. So let's create a poll here, you guys. Start a poll. All right. What we name the GPT. So it's good news, you guys. Good news. We can train it. I just have to figure out where the memory leak is. That's it. We just got to figure out where the leak is. Once we find the leak, we're good to go. We're good to go. So let's see. We'll see. What do we name it? So you said Jarvis. You said Chappie. I like that. Chappie. I only have 4 options, I think. So let's see here. What else? What did you guys have? Let me see. Yeah, real quick. Let me bring this down. All right. So good to have you guys here. Let's see. Rust GPT, Steven GPT, Rust GPT / Steven GPT. Well, probably, yeah, GPT. What else? We got so many options. GPT. And then, so let's see here. Jarvis, Rust, Bbot. I like Bbot. That was good. Leaky AI, right? I know, right? Because we done broke it. You never want to see this right here. Ooh, that's bad. Ooh, that's bad right there. The good news is, though, we figured out what the problem was, so we can actually train it. We just need to find the leak. We got a leak, you guys. We got a memory leak. What? You want to watch it again? You want to watch it leak away? Right here. Watch this. 39, 48, 52, 54. Oh, 61. Oh, that's not good. That's not good right there. Oh, that's a problem. Oop. Yep, right there. All right. So it's definitely got to do something with the training data, I think. Do you have a pet? I don't, George. Can I ask to name it myself? Can you ask to name itself? We actually could. We could. Oh, whoa. Hey there, Mr. Jackson. Thank you for the gold coin. I appreciate it. Good to have you here. Happy Thursday, Mr. Jackson. Thank you. Bumblebee. There we go. That's another good one. Salute. Thank you. All right. Blumbee. There we go. Okay. Here's some options. I put them up there so you guys can vote. So you guys can vote there. Let me know what you think. Thank you again for the gold coin, Mr. Jackson. All right. So let's find our leak, you guys. The good news is, oh wow, we've got quite a bit of time. We got about an hour. We get an hour to find the memory leak. Do you think we can find it? Do you think we can find the memory leak? All right, we're gonna try. We're gonna try it. So the good news is, the leak is in here somewhere. It's around here somewhere. I think it's this code. That's the problem. Right here, I think it's this code. I'm pretty sure. So let's find specifically where it's at. All right, let's go down here and we will comment all these things out. Save and run. Okay. Nothing's leaking. Oh, wait. Oh, a little bit. Nope. Okay, we're good. Okay. So we didn't see any leaks there. Marker. Hey, how's it going there, L Marker? Good to see you. Welcome on in. Happy Thursday. We're almost to the weekend. Are you using NeoVim or regular Vim? I am using regular Vim. Check this out right here. Ordinary Vim version 9.11752. Ordinary Vim, you guys, right there. Blumbee? Are you guys serious? You want Blumbee? Really? All right. Goat. Got the goat. Oh, there. Thank you. Appreciate it. That's very nice. I like that. That's one of my favorites. Got the goat. Yep. I really like Vim. Vim is my favorite. Makes me really happy. So Todd Green, my co-founder. You guys know Todd Green? He's around here somewhere. Where is he at? Let's see here. Where do we put him? Nope. Where are we at? Here. Those are my educations. We don't need to worry about that. Where are we? Todd, here we go. Todd Green. So here's Todd Green. Check Todd Green out. This is CEO of PubNub, co-founder at PubNub. We are the #1 developed platform for real-time experiences. Yeah, that's us. That's us. Todd is the one who's like, hey, Steven, you should try out Vim. You should try out Vim. And I was like, okay, let's try it out. A long time ago now. Long time ago. Vim, there you go, Cal. Yep, that's it right there. Do Chappie, Vortex Chappie. Ooh, that's a good one. Vote. Vote. Yeah, gotta vote. Bees are hardworking, therefore. Blumbee, there you go. Is he a VC too? Well, I mean, I will tell you. Yes, yes is the answer. There you go. Yes, easy. We don't have to go any more details than that, though. Yeah, we don't have to go any more details than that. The answer is yes. Okay. Okay, here we go, you guys. Here we go. So, let's see if this is going to leak. Will this leak right here? Is this the leak? This might be the leak. We might need to figure out how to deal with this. I'm not sure how, but we will. All right, let's try it. Are we leaking? No, we didn't have any leaks that time. Okay, so let's try this. Leak here. So my guess is no, there's no leak there. Right, looks good. No problems, all right. Okay, so what about if we turn them into tensors? Is this where the leak is? Do you think this is where the leak is here? Here we go, here we go. Guess we're gonna call it Blumbee. I guess Blumbee's the answer. All right, no leak now. I don't see any leaking. Okay. So let's try the loss. So we won't throw it into the optimizer yet. Let's try this. This might be where the leak is. I have a strong feeling here. No. Oh, yep, right there. Okay, so we found it. We found it. This is where the leak is. We found it, you guys. Okay. So it's somewhere in here. It's in here somewhere. We don't know where, but we will find out. Phonetically, Blumbee is awesome. It's very satisfying, isn't it? It's very satisfying. Is it a leak or information not being absorbed? In this case, it is straight up a leak because you can see how much our memory explodes. So it is significantly leaky, right? Watch this right here. Our memory, we don't want that to go that high. Yeah, and it just grows forever. And it causes our stream to get sad. So the good news is it's not here, which if it was there, I would have a hard time really figuring it out. We have it here. So is this... We need to figure this out. All right, so let's see. Is it in our forward? Let's try this. Now we need to isolate it. Let's do a little bit of binary search here. Is it in our output? It is. There it is. It's right there, you guys. Hold on. All right. So I think this is the line where we're getting the leak. So let's try this. All right. Let's see now. Let's see. Hey, how's it going there, Vanish? Good to see you. Welcome on in. Happy Thursday. Good to have you here. It is there. Okay, I found the line. We found it, you guys. Here's the leak right here. Now, how do we deal with it? How do we deal with this part? I don't know. I've not really had to deal with them because this goes out of scope. It's gone. It's out of scope. So, we need to figure out how. So could we say, what if we did this? What if we did this? Let mute output equals, let's call it regular out for now, make it easier, is a tensor. Let out is a tensor. And then it would be, I don't know, tensor from 1 for now. And then we don't redefine it, we just assign it. Will that work? No more leaking? No more leaking? Oh, no! Oh, darn it! Okay, no, it's leaking. Right there, you can see it. Yep. We don't like that. That's not good. That's a problem. Right there. BRB sounds good. Good day, Steven. Hey, Sid. Good to see you. Welcome on in. Happy Thursday. Good to have you here. All right, that's a leak. That is absolutely a leak. Okay. So, let's see here. Let's go into our Jiminy. Okay. Let output is leaking Rust TCH. Let's see. I'm not sure how to fix this because it's not my library. I didn't write it. It's not my library. So bees live in a hive. Maybe Blum hive. There we go. I like that one too. Hey, Rox, good to see you. Welcome on in. Happy Thursday. We are almost there. We're training. We have a problem though. We have a leak. We have a memory leak. And we're trying to fix it. If we get the memory leak solved, we're good to go. Here we go. No grad. No, we want the grad. We need the grad because we're... Let guard? No guard. No grad guard. What's this? Accumulating tensors without detaching. Okay, if you are collecting the outputs of the forward, storing predictions, losses, every entry in the vec is holding onto the entire history of the operations that's created it. Okay. Use detach and shallow clone. Detach. Okay. So we can do this right here. We can do a detach. That might be the answer. If we're doing detach, then it's going to be... Will it still be on the NPS? You guys know? How do you get those diagnostics in the terminal? Which one? Which diagnostics? Oh, you mean HTOP? Right here? This right here on the screen? This is just HTOP, right? So you type in HTOP, press enter, and it gets... You have to install it. It doesn't usually come installed with operating systems. You have to say brew install HTOP, yum install HTOP, apt install HTOP, right? Or what is the other one? APK add HTOP, right? Lots of options there. The good news is we will be able to train this live on stream. So you said .detach. Like that. Here we go. We don't need to define it up here. Cool, thank you. You're welcome, Sergio. You got it. All right. We have 40 minutes. We're good. We've got 40 minutes. All right, let's see if this works. No leaks, no leaks, no leaks. Oh, no, it's leaking. That is a straight up leak right there. Hey, look at that. Hi, everyone. Good to see you. Okay, so it's leaking still. I don't like that. All right, let's close that out really quick. Maybe, let's see if we can still optimize it. Let's see what happens. Okay. Let's see here. Run. All right. Let's see what happens. Oh, we got to, because of detach and it's on the wrong device. Element 0 of tensors does not require grad and does not have a gradient function. All right. So detach might not be our... Well, it wasn't working anyway, right? So can we do this? How about that? See if that works. No errors, no errors. Okay. I'm not seeing any errors, but I am seeing the leak still leaking. Okay. You guys, today it turned into a stream where we have to find and fix the leak. Let's see if it slows down. I don't think it's going to slow down. I think it's just going to keep going. It's just going to keep going. Yeah. Okay. Good thing we have plenty of memory to deal with. All right. So here is the bug. All right. Let's see if there's any more details in here. Forward. Update the forward method to accept references. Forward and tensor. Well, we're not doing that, I don't think. Oh. So what if we did an and tensor here? Okay. Is that gonna work? Okay. No, that was the wrong forward. We need the right forward here. Let me see. Hold on. Okay. Is this the right one? This is our transformer block. Is this it? Yeah, okay, so we need to do reference of tensors everywhere. You'll be joining regularly after Rust GPT comparison. Oh, Rox, that sounds great. That sounds great. Yeah, so Rox, we will be going into doing a RAG, retrieval augmented generation, vector store, SQLite for full text search, and a couple other things in the metadata. We will create it and compare it for a large chunk of data. I don't know. We need a data corpus to train it against. And I think we're going to be good. I think it'll be really good. Okay. So our forwards need to have an and tensor. And tensor. So everywhere we have a forward, we need to do an and tensor. Input. Here we go. Like that. Okay. Looks good. Yep. Happy there. All right. Forward. All of our forwards need to be a reference to a tensor. Yep. That's good. All right. Tokens. Forward. And no. Yes. And of the tensor. Next. And tensor. Forward fine. Looks good. Block dot forward needs to be the reference of the out. However, let me see here. This might cause a whole bunch of problems, you guys. We'll have to fix it. Minecraft music. All right, yeah, let's do it. After my favorite song. This is my favorite song right now. I like this one. It's called Splashing Around. Once we get past this song, we'll go to Minecraft music. Let me see here. All right. Forward. Self ampersand. Forward. Here we go. We're going to do an and tensor. Yep, that seems fine to me. Yeah, okay. Forward and tensor input is already good to go. Okay. So I think we got them all. I think we did it. This is everything. All right, let's see if that works. Expected and tensor found regular tensor. Okay. Line 89. Embedding is going to be an and tensor. Okay. Whoa, all right. Now, do we have no leak? Did we fix the leak? No leak. Here we go. Oh, I don't know. No, it's still leaking, you guys. It's still leaking. But at least we're passing them by reference now, right? So that's a nice bonus. That's a nice improvement. Okay. It's going to even out. No, it's just going to keep going, isn't it? I'm just waiting for a second. All right. Yeah, it's still going. Okay. So, train. Here we go. FN train. Okay. Yep. Tokens. Then we've got our training data, training sets, and features. That should have done it right there. Right there, that should have done it. Okay, we got the Minecraft music going. The leak is exploding. Hardcore. Look at that. Oof. That is some heavy leak. Okay. Drop. Oh, we have to use the drop. Okay. Explicitly clean up before the next iteration. This is what I want. Yes. Okay. So let's see if we can do that. Let's do drop. I've not used drop before. I didn't know it was a thing. I never needed to do that. I've always relied on stack. So clean up, drop out, drop the features, and drop the labels. Label tensor. All right. Oh, wait. I typed that wrong. There we go. Here we go, you guys. All right, drop. Is that going to save? It does. Okay, now, will it not leak now? Are we better? No leaking. No leaking. No leaking. No, it's leaking. Darn it. Okay. That didn't fix it either. Okay. The good news is it's learning. It's definitely learning. It's just leaking all over the place. Oh, yeah, we got it happening. It's happening. Do we want to also... I don't think we need to free these guys. Those are already freed. Okay, let's do this. Let's try this. Features, labels. I'm pretty sure that's not going to fix it. No, not working. Before next fix, do a poll of does it not leak? Oh, right, yeah, okay. Does it not leak? There we go. All right, so, all right, in poll. Okay. All right, I will get that one ready. All right. Wait, let me stop that before it explodes on memory. I don't want to swap anymore. All right, will it leak or will it leak again? All right, we just applied another fix. Okay, here. Okay. So it's not that. Let's see. I did all the addresses of tensors. I did that. Detach doesn't really do the trick. And shallow clone, if you want a pointer, we don't. All right. If we do no grad... Wait. Let guard, no grad. Alternatively, you can use a guard if you prefer. I do like a guard. All right, let's try this just to see. I don't think it's the answer though, because it's the feed forward that's the error, not the gradient. Although it could be the gradient, I highly doubt it. All right, so that will prevent it from learning. So we should not see a drop in the loss. Or it just crashes altogether. Tensors does not require gradients. Yes, okay. So it just didn't work at all. That's fine. So let's hide these things here. Okay. Here we go. Let me just try this really quick. Wait before it moves fixed. All right. Wait. Okay. We don't know if this works or not. We don't know if this works. Okay. Here, let's do another poll. Let's do a poll. All right. Will this next fix that we just did, it's not really a fix though. It's not. It's just going to tell us whether the internals are good or not. Okay. Will this work? Okay. 1 second. Start a poll. All right. We're going to say, 1 second. Will this guard fix the leak? All right, this time. All right, I'll let you guys think about it. While you guys are thinking about it, I'm going to be reading more options. I'm just going to be reading up on this. All right, let me see here. La. Okay. Yep, all right, looks good. Okay. Step loss. Okay. Ah, yeah, that would be a lot nicer. Okay. All right, will it leak? No. You guys, you got to say yes. Did we fix it? Oh, wait, no, actually, you got it right. You got the answer right. All right. So the question was, will it leak? No, or did we fix it? Let me check the poll again, right? Will this guard fix the leak? Everyone's saying no. I think you're right. You're right. I think you're right. Okay, 100%. 100%. Okay, so are you ready? We're going to find out right now. We're going to find out. Will the guard fix the leak? The answer is no, probably. The answer is no. Here it goes. Oh, yeah, there. Oh, it's growing. You know what that means. You got it right. You got it right. Let me close that off. Yep, that's still broken. It's still busted. The good news is we know exactly where the problem is. It's this line right here. So if we comment this out and we let it run, it won't leak. You pray that GPT gets created very soon, and once it's ready, you will be giving you a free subscription to it. Oh, well, sure. Here's the deal, though. You won't want to use it because it's just going to be me talking. It's just me talking. That's it. That's literally it. It's just me talking. And you don't want that. You don't want it. I don't think that's something that you're going to want. That would be really funny, though. All right. Getting the music going again. All right, C418. You guys know what that means. Yep, see, that worked. All right, so this is where the actual leak is, right here. So this is it right here. So detach didn't work. See. This is where the error is, right here. All right, forward features detach. Detaches the tensor from the computation graph. Do we want to do that, though? I don't think so, and I don't think that'll do the trick. Even if we detached it right now. Detach. It's still going to leak. We'll still see the leak. It'll still leaking. Bro, can we run your GPT locally on our machine? Yes, you would be able to because it's really small. See, it's leaking. What we need to do is fix this. We got to fix this right here. Before, obviously, because it'll explode your computer. So, detach didn't work. All right. So, delayed CD allocation. Drop. Explicitly clean up. We already did that. Okay. We did that one. We did passing tensors by value. We did that. Accumulating tensors without detaching. That didn't work. We tried the guard. That didn't work. We don't need to do no grad. Because if we did, that would be a problem. We need the gradients. All right. We need grads for training. We need grads training. I think it's 1 million. Wait, what's 1 million? How much billion parameters does it use? Oh, it's in the millions. Yeah, it's in the millions. It's not in the billions, even close. It's not even close in the billions. You know what would be funny? If you were already AI, you created so seamless. Yeah, that would be. If I was AI, you wouldn't know. I mean, because it's so good. Or, I mean, you can't really tell. Yo-ho, bro. Good to see you. Arsenal. Good to see ya. Welcome back. Happy Thursday. Good to have you here. We got a memory leak, and we got to fix it, you guys. We got a memory leak. Okay. We need training grads. This is output in training loop. This line fails here. Oh, wait. No, not that. We need this here. Where is that? This line right here. This is the line that fails. All right. Copy, copy, copy. When commenting out this line, the leak stops. So we know where the leak is. At least we know where it's at. Thanks, bro. Yeah. Good to have you here. All right. So if this is happening inside your training loop and you absolutely need the gradients, yeah, we do, then no grad is obviously out of the question. Obviously. But we tried it anyway. You are accumulating loss or metrics without extracting their values. If you track total loss... Are we, though? Are we really? So we've got the... Hold on. So we've got our output here, which are our logits. Let me see here. Subsequently, it means the memory is being captured further down the loop. I don't know about that. I don't know. Leak, this keeps the entire backward graph of every step in memory. We're not doing that though. We're not doing that, I don't think, right? There's nothing, none of that happening. No. Zero grad output, lost backward, optimizer step. Oh, VStore. Oh, clear the previous gradients in the VStore. That's where we need it. That's why, right there. Okay. We need the VStore. We need the VStore, you guys. Okay. So, this is all right. So we're calculating our gradients here. I don't know if that's going to work or not, though. I really don't. I don't know if that's going to be the answer, but it would be nice if we saw it. Are you using multiple softmax? Yeah, I think so. Softmax. Here and here. We're doing this to capture the logits for negative likelihood loss right there. And for our self-attention. And transformer, what do you, LSTM or GRU? This is not an LSTM. I don't think it's a GRU. This is just GPT. This is the, this paper right here. You know this. You know the one, right? You know the one. Read your other message. Wait. Is it me or can't I pin anything? Oh, if you want me to pin something, only I can do it. Only I can do it. It's just me. All right, let's go back over here. Mail, no, thank you. We don't want that. All right, here we go. All right. Good news, we have 20 minutes, but we have a good 20 minutes. We have a good 20 minutes. No, I don't want mail. No. No mail. Okay. So, where are we at here? So our log it. Let me see. Yep, okay. So, let's see if we can figure this out. It says that we need to zero the gradients on the VStore, which we didn't, or optimizer. Oh, we did that though. Oh, we are using that already. We're already doing that on the optimizer. Darn. Okay. Targets and data set. Okay. Let me see here. Let me see. Let's try this. All right. Maybe we just need to put it up here. Do you think that'll fix it? You think that'll fix it? I don't know. We're going to find out. Here we go. All right. Moment of truth. Here we go. We also don't need this. Okay. Let's get rid of this. Will this be the ultimate fix? Is it going to work? I don't know. We're going to find out. Oh, I see. Use multiple LSTM models and encoder and decoder to create your model. Oh, Arsalan. Yeah. All right. That sounds like a good plan. Give the AI all the code and the entire... Yeah, the AI will fix it. It will. It will find the problem. It will. Here's the good part. We want the struggle. We want to hunt it down because it's going to get our brain to remember. It's going to get our brain to remember. All right, here we go. Also, we might have figured it out. We might have. Oh, no, still leaking. Darn it. Darn. Okay, I was almost convinced that it was going to be the answer. Nope, it did not. It did not go. Okay. Let's see. Missing torch context. Missing context are explicitly drops in a loop. Rust drops tells C to free the wrapper, but libtorch internally allocator delays the memory. Okay. Yeah, we tried that already. That didn't work. Okay. Summary. So, none of those work. Nothing works. Still leak on the feed forward. Oh wait, maybe the leak is somewhere in our feed forward. Right? Because since we know this is where the leak is, maybe it's leaking here. Right? See here. All right, so it could be somewhere in here. Right? It could be in here. It could be in the attention. It could be in a lot of places. So how about we do this? Let's see if we can hunt it down. Let's see if we can find it. All right. So let's do this. Let's grab, let's hide this for now because we don't really care what the out is. We will print the out. Out.print. All right, so our leak is happening here. We'll see a bunch of numbers on the screen, a lot of numbers. And then is our leaking going to increase? It doesn't seem to be. Hold on. Wait. Try that again. What editor and how are you using AI? So this is Vim. This is the Vim text editor. So that is still leaking. Okay. Let's see here. So that's fine. So what I need to do is, which AI are you asking for info? This is Gemini. I'm doing Gemini right now. And it didn't get it right. It got none of it correct. It was wrong 100% of the time. Oh, yeah, quick fix. You got it, Gemini. You're working on a movie selector that helps you choose. Oh, wait. What movie selector? Is this new? All right, forward. Here we go. I need to see the forward here. And this is this forward, right? This is a transformer. This should be the transformer. Yes, okay. All right, here's our forward. I'm going to... Wait, why is that mutable? I forgot we had to do this. For the positional encodings? Oh, because we're blocking. Oh, here. Got it. Okay. Let's do this. Return out. Like that. Just return out immediately. All right, let's see if this leaks. Oh, look at that. Hey, we're getting closer. Hey again, hey Toop. How's it going, Toop 101? Good to see you. Happy Thursday. All right, so that worked. All right, so is this the problem? Here we go. Is it inside the block? Is it gonna grow? Is it gonna grow? Oh, it's growing. It's growing. Okay, we found it. We found it. Yeah. Is it? Wait, it stopped. It stops growing though. 47. Is it gonna go higher? I don't know. It seems to have stopped. Huh. Okay. Weird. Okay. So there's a little bit of growth here, but you expect that because we're training an AI model with millions of parameters. So are you using AI to code are you using it as a Google search? Yeah, we're doing it back and forth like a Stack Overflow. Exactly, like a Stack Overflow. And we're doing that just to give us like a little bit of hints and ideas of where to go. We are writing it by hand on purpose because this is a learning channel where we learn how to code and build things, right? So that's the big part of the trick here. It's definitely not on the output projection. If I do this, let's see if it goes back up to where it was. So I want to see that growing. So it went to 42, 49, 50, 52. All right. Hey, Joe Blow, thank you for subscribing. You joined the right channel for software engineering. Good to have you here. Happy Thursday. We are currently building ChatGPT in Rust, and we've got a memory leak, and we're trying to figure out where it's at. Where's the memory leak at? So we are seeing that it is leaking in this range here, somewhere around here. So what if we bring this back here? See if it leaks again. Because it could be in the block. I'm just going to let it run for a second. See how the memory doesn't grow? It only grew a smidgen, like a gigabyte or so. Peeking into rooms prior to the entrance. Whoa, hey, what do you mean by that? Wait, good luck. Good luck. What do you mean? I guess technically we're kind of doing that right now. Maybe multiple data leaks. It could be, right? Right? It could be. So, as you can see, worked out fine. However, if I put the return here, let's do this break. Let's do one. We'll do one block. One block. 34, 35, 37, 40, and then it stops, which is fine. I can deal with that. Oh, wait, it went to 41, 42. All right, let's see if it just keeps growing. Here, what we need to do is open up our main file and set the number of epochs and batches higher. Hey, Prashant, thank you for subscribing. Welcome on in. Good to have you here. You joined the right channel for software engineering. That's what we're doing right now, you guys. Right now, all right, so I'll do like 1,000. We'll do 500. 500, 400. We'll say 400, 400. Okay, so it seems to have stopped at 44. Let's see if it keeps growing. We'll just let it grow and grow and grow. Mohammed, hey, good to see ya. Welcome on in. Good to have you here. We're currently hunting down a memory leak. That's currently what we're doing. We're trying to find it. And we are getting close. We're getting very close. Good to have you guys here. Bro, are you using JavaScript? We are using Rust. This is Rust. And we are using a C++ library called libtorch. And it's possible that we just need to do something extra that we're missing. Which AI is the best in your opinion? The best one for coding and that has been optimized for the most on coding is going to be between, of course, Opus, GPT-5.5, and Gemini, right? Those are the best for coding. Now, each of them are a little bit different for different languages. Like Gemini has a harder time with Rust, I've been finding, though it works perfectly fine for JavaScript and Python. So it seems to have stopped at 42 gigs right there. It seems to not be growing anymore. So it made it up to 42 gigs. Now, let's put all the blocks in there. All right, 42. Yeah, it only got to 42. Let's see if we can make it go to higher than 42. So not just one block, but 4 blocks now. Oh, hey, look at that. It went to 47 immediately. Okay. So if it's at 50, so that means that it might be in our block somewhere. Yeah, look at that. It's growing, you guys. Okay. So this might be where our problem is, right here. So in our block forward. So let's see here. Transformer block. And then our forward is this. Well, it would have been great if it didn't have to be this. However, you know what? There's a lot going on here. There's just a lot going on. All right. So we can just say return out here. And let's see if that does it. It might crash. 1 second. On our forward. Where was that at? On our original transformer with the blocks. Here we go. All right, we have to say break. We have to break here. And return out. The only thing is if we do that, I'm not going to be able to... it's not going to... Let's see if we can make this work. I don't know if we can or not. I don't think this will work. Well, it is. Okay, fine. Learning for a day. Did day work? You manually code or use AI? Yeah, on day-to-day work, I use AI. For learning, I don't. That's really what the answer is. Don't use AI if you want to learn how to use AI effectively. Use AI 100% of the time if you're being productive. Basically, if you want to learn something, just don't. That's it. It's that easy. The best of AI for coding, no AI at all. All right, it's needless source of entropy. Skeleton. There you go. Right? We don't need to use the AI at all. We can just code regular. So let me see here. Okay. So that seems to do the trick. I think we're fine here. So we can just keep doing this. All right. So if that's the case, let's see our transformer blocks. Here we go. Let's go back to our forward here. Okay. No, transformer block. Yes, perfect. Oh, I got 10 minutes, you guys. You heard the 10-minute alarm. We will figure this out. All right, so where do we think the error is? It might be in attention. So it could be around here somewhere. See, here's the problem. Let's just return out here. So wait. Did we get that? Yeah, okay, good. Okay. 36, 39, 40. Okay. So it might be in here somewhere. Probably here. Right? That's where my guess is. Is it in here? So if that's the case, yeah, looks like it. Okay. So this might be where the leak is in our attention mechanism. Because if we return out, so made it to 44, right? So if we run it here, there will be no leak now. Like none. Okay. So we're narrowing it down, you guys. We're narrowing it down. We almost have it. So I believe the answer is here. Let's try this. Attention. Here we go. Okay. So it's somewhere around here is where we're having problems. Somewhere in here. 2-pack. What's a 2-pack? Let's see. No, Michael Jackson. Oh, Michael Jackson. Yeah. I like... Exactly, George. Exactly. Michael Jackson. With all due respect, in which role of software engineering you work? What is your role? Oh, yeah. Okay. So I've started my own company. It's called PubNub. I'm the CTO. We started this over a decade ago now with my co-founder, Todd Green. We raised $134 million. We are at Series E right now. Over 1 billion devices on my network today that use it for communication, right? Communication like multiplayer games, in-app chat, which is what you're doing right now. You're chatting to me, right? So that's my technology. The top 10 apps in the App Store all have built-in app communication. That is the APIs that communicate with the phones. You need a service that can provide this. And that's what we do. That's what I do. So if you're building sports and entertainment, multiplayer gaming, telemedicine, where you have the doctor and patient talking to each other on the phone. You've ever talked to your doctor on your phone? All right. Then you might be using my technology. E-commerce with live auctions and live bidding. Fintech with stock quote tickers. You see the updates, prices jump and go up and down, right? Chat support, ticketing, and my favorite, on-demand economy, this delivery. You press the button to order lunch and you see the driver on the map arriving near. It's gonna be here pretty soon. That's what I do. This is my company. Yeah, Muhammad, no, right? It's good. It's so good. Michael lives on, you know it, in music. Every day, you guys, every day. Oh, let's see here. Did I? Okay. 37. Okay, so where is this at? Attention here. So let's see this again. Let's run this again one more time. Okay. Is it going to grow? It seems to. It does seem to grow. Okay. So I believe the growth is here. All right, so we got 5 minutes, you guys. We got 5 minutes. And then the plan is all right, we need to plan this out, you guys. So I need to fix this leak. I need it to train on Steven data, which we've already done. We've already got the data for Steven, which is great. Then we need to test it and play with it. That's it. That might be tomorrow. I think that might be tomorrow's plan. By the way, I went on this one app that was the same website and I put something equals and something equals B. Oh, something equals A and something equals B. And I printed it to make them together and it didn't work. Or what were you trying to get it to do? You're a little mind-blowing the person, Steven. Oh, thank you. Appreciate it. That's very nice for you to say. How did we get the data? Oh, it's all our transcripts. So you see all the text here on the screen. I save all that. It's all saved. And so all the words that we say, by data, Steven text right here. Hey, look at this. I'm like, happy Sunday. We're going to continue our ChatGPT Rust. We're gonna have a lot of fun I think we're gonna get multi-headed attention today. Remember when we did that? Remember? That was a long time ago. That was great. Right here. So that's a lot of data. It's a lot. So that is how much data? That is 3 megabytes worth of Steven speech. Oh, cool. Sounds like a good Friday. Yeah, that'll be the plan for Friday. So let me see here. Let me see real quick. Okay. So we got 4. Yeah, it's still leaking, which is good. That means that the answer is inside of our attention. It's right here. This is where the answer is. And these should be, maybe we need to do this, right? Let's do tensors. So FN attention, we'll do and tensors. Like that. Okay, because we missed those. Let me see here, my query. Okay, save, no errors. Okay. Did we fix the leak? That would be so cool if we fixed it like 4 minutes before I have to leave. Oh, darn it, it's still growing. Okay. I thought that would have been really cool. I'm like, hey, look, we did it. That would have been so great. That would have been like the perfect end to the stream. My company has given me Claude Code. Hey, very nice. Microservices faster and I have less time to understand this, the code that the AI, and it's taking all the joy. It's taking it away. I know. Hey, don't worry. The joy comes back in a different shape later on. It does. When you have crafted many decades or years spending time honing on your expertise with software engineering, and then the AI does all that for you now, it's kind of a letdown, right? Oh no, I can no longer deal with my craftsmanship. I know, because it's taken away. Good news is it eventually comes back in a different way. You still are excited to build, even with the AIs. Hey, how's it going? What's up? I learned how to connect a registration page with a custom CRM, customer relationship management system, using Firebase. Awesome works. I can't even if the website is not live and just living locally on your computer. Oh, hey, that's great. Very nice. Yeah, that's excellent. Thanks for today. Have a wonderful rest of your day, sir. All right, sounds good. Good luck, givers takers. Appreciate it. We've got a good plan for tomorrow. We're gonna get this going, and we're gonna play with it. We're gonna have it speak Steven. That's what we're gonna do. So AI made it easier. It did. And here's my question. I'm like, where's all the productivity gain? Where did it all go to? Yeah, we can do a lot more features faster, but it doesn't seem to be having any outcomes, as far as I can tell. Right? It hasn't really changed much. It hasn't. I'm looking at the numbers and I see, okay, we're spending X on AI tokens, and I'm looking at Y dollars, and I'm like, the numbers don't match up. They don't. What are you doing? We're building ChatGPT in Rust. We have a memory leak, and we're trying to find it. We found it here. It's in our attention. So it's somewhere in here. We don't know where. Let me return the query. Is that going to work? Oh, can I dereference it? No? Okay. What we can do is we can return a tensor. Return a interesting. Do you think that? No, we got to return the tensor itself, not a reference to the tensor. Okay. Cheese aside, it's about the story. Yeah, it kind of is. Yeah, it is. It's true. You got it. Been building landing pages and class regression websites for my auntie using AI. It's pretty fast. It is, right? It's really good. Most of the time your AI is hallucinating. Yeah, it does that, doesn't it? Tensor from slice one. Okay, save. No errors, right? Mismatch integrated? Wait, what do you mean? Oh, what do you mean? How about slice like this? Okay, there you go. All right, let's see if that leaks anymore. I should see no leak now, right? Theoretically no leak. It's still leaking. Okay. All right, you guys. Thank you so much for joining. We had a great day. Hey, I was going there. Prontos is any URL this sex. Oh, in Minecraft playlist? I don't know. Oh, wait. I was 30 minutes off and we have a memory leak. I know if you push the code, I can have a look tomorrow. Sounds good, Foo Dude? All right. I will push the code. All right. Don't be careful. It will crash your system. It will crash it. All right. Where are we at here? All right. So, let's get rid of that. Okay. Here we go. Break. We know where the leak is. It's in the attention. So let's see here. All right. I'll push the code really quick. FN attention. Here we go. Okay. To do leak here. I think. Maybe. All right. Here we go. Let's copy and make it pretty. Here we go. Pretty. Okay. A whole bunch more. And then we will git add, git commit. Oh, wait. No. Hold on. rmdata all.srt. I don't want that. rmdata all.text. All right. Git add here. Steven data. rm. We don't need the scripts either. -rf scripts, because that was just a temporary thing. Git status. Git add. All right. Steven text main and transformer. Git commit am finished optimizer, but we have a leak. There we go. Push origin main done. Boom. All right, you guys. Have a good day. Sergio, Kyle, Quick Fix, George, Foodude. Good luck, givers, takers. Oprotons. Oprontos. Thank you guys so much. I'll be back tomorrow, and we'll get our GPT because we finished the optimizer. We got the loss. It trains. It just has a leak. We ran into a leak. Hey, bye, Blumby. Hey, thank you guys. See you guys tomorrow. Have a good rest of your day. Bye, everybody. Have 120.